I want to say thank you to Norman for doing this. This is our, I think this is our biggest Zoom yet in terms of registrants. And it's about, I see we got 91 on board right now. And that was about the most we ever hit when Ken Kessler did this a year and a half ago, when Zooms were a new thing. So I think it's a tribute to your reputation, and to your topic, noise and vibration from an audiophile's perspective. I think a lot of people are interested in that. Norman, let's start. You were in your bio, I noticed you were a musician, a hi-fi shop owner, designer at MIT Cables, consultant at Skywalker Ranch, technical manager at Owens Corning. That's just an amazing background. And do you think, does that make you uniquely suited to do what you're doing now, which is kind of bridging the pro audio, studio audio, and audiophile consumer worlds?
Yeah, I think that I like that you see that parallel, because that's what is of interest to me, is correlating sonic attributes with measurements. And so that's been something of interest to me for decades. And one of my pursuits, especially while at Owens Corning in the Science and Technology Center. And then, through various associations trying to make changes that will be of benefit. Now, this takes generations to do when you're trying to correlate subjective with objective measurements. But that is something that, especially in our industry, we need to work on, so that we are all communicating better and more on the same page. So yes, that's I think I'm because of my background. It makes sense.
Yeah, you're an audiophile who actually knows and understands measurements. That's
yes. And music and
music,
and
right?
All of that, yeah.
Right. And there are a few people like you around, but not too many. So that's wonderful. And I should also mention your website, AV Room Service, and recommend it to people. I really love the videos you have. If people go to avroomservice.com, you can go to acoustics, and then there's a pull down to get to videos. And there's some fascinating things to not waste your time with. Lots of good stuff there. And and some interesting products. Like we first learned about it through Bob Katz, the mastering engineer and former recording engineer for Chesky, who highly recommends your EVP isolators. Actually did measurements with his speakers and wrote an Audio Engineering Society paper about it. So they're really very effective. And that's been around for a while, but I really urge people to take a look at AV Room Service. So now, Norman, I'll let you do the screen share thing and start your presentation.
All right, sounds good. Thank you. Let's see if I can do this. All right, so I'm going to be covering noise and vibration from an audiophile's perspective. And we are going to cover what the fundamental sound quality attributes are for a critical listening environment, how far off the typical listening environment is from the desired, what these sonic attributes mean to the experience, how these sound quality characteristics are measured, and solutions to common problems. We're going to talk about fundamentals, meaning we are talking about large obstacles that get in the way of our experience. And we have to get rid of those large obstacles. We have to do the coarse tuning before we can do the fine tuning. And there's a hierarchy regarding that. There's a priority checklist, if you will. In other words, if we don't follow that hierarchy, then we are not going to gain the benefits that are available. We're going to break this up into two primary sections. The first half, we're going to talk about acoustic noise and vibrations. And the second half, we're going to talk about electronic noise and vibrations. And we're going to talk about specifications and meaningless versus meaningful. And what I mean by that is that there are specification sheets that we tend to drool over, study. For example, total harmonic distortion of an amplifier, you know, oh, this one's got 0.00 and this one's 0.006 or whatever. Damping factor, slew rates, you know, things like that they're important, sure, but they're not important if we can't hear them, right? And we typically can't hear those things because our environment is in the way. So when I say meaningless versus meaningful specifications, the ones that are really important are the ones, the acoustical measurements in our room. Those are totally getting in the way of the specification sheets, if you will, of the equipment. So do you know, for example, what the ambient noise floor is in your environment? Do you know what the reverberation times are in your environment? Do you know what the ground impedance is for your electrical system? So this is the big bold statement here. And really, I believe this is a conservative statement. My experience says, I would say that more than 90% of the audiophiles are experiencing less than 50% of their equipment's potential. And that's because of the acoustic and/or electrical environment getting in the way. So you put this big investment in, and typically we're forgetting about what's most important. So why is this? I believe there's several reasons for this. One, they may be inexperienced as to the potential. I think any of us have, regarding anything really, until you've experienced it, you don't know what the possibilities are. Secondly, they may be unaware of what the obstacles are preventing a better experience. They may not know how to control those obstacles. There may be constraints preventing them from achieving their goals. They may be wife acceptance factor, or they might be budgetary, or they might be physical constraints, or maybe they're in a rental, and so they can't do certain things. But I think one of the biggest ones is they are told the answer is to buy better equipment. And what happens there is you end up just chasing your own tail because you're not addressing the problem. So another way to, well, so what are audiophiles doing in the meantime? So looking at this chart on the left-hand side, this is the typical action taken to improve the audio experience versus on the right-hand side, this is the typical impact on the audio experience. And if you look at those, they're almost flipped. So on the left-hand side, the action that's typically taken is new equipment, upgrades, tweaks. There's very little interior acoustic treatment or physical setup addressed, very little vibration isolation or resonance damping. And that the typical impact on the experience is quite different. The interior acoustic treatments and the physical setup, that's the priority. And next to that is going to be vibration isolation, resonance damping. And once you've got that under control, now you can start addressing new equipment, upgrades, and tweaks. Now, again, I'm totally generalizing, you know, but you can't have, for example, let's say you've got state-of-the-art equipment and it's in a typical environment. You know that that investment is not going to perform up to its potential. On the other hand, if I had mid-fi and I had it set up right in a controlled environment, that's going to outperform the state-of-the-art equipment every time. Another way to look at this is this, for example, this is my philosophy, that setup, calibration, and acoustics outweigh electronics. You can't turn it the other way around. So in this explanation, in our scenario, who's the audiophile? And in my book, it's a person desiring to recreate the artist's musical work accurately through an audio playback system in a small room. So what defines a small room? In our audiophile scenario, it's a space that meets the following criteria. One, can apply sound source frequencies whose wavelengths are longer than the longest dimension of the space, incorporates shorter decay rates than performance spaces, has strong early reflections compared to the direct sound. So those are the criteria for a small room. In addition, our typical audiophile room includes the following acoustic characteristics. One, decay rates that are unique and vary wildly by frequency. And we'll get into this here, but everybody's room, if it's not under control, is unique as our voice or our signature or thumbprint. They're all different, and we don't want that. We want to have some control. We want to have some neutrality. Unique room modes, I think most of us are familiar with that as well. High ambience noise floor, something that we're often not addressing because we typically don't know how. And only a standard electrical service, and that's definitely limiting us. So ideally, the goal is for a neutral environment, one that doesn't add or subtract, one that does not introduce unwanted vibrations. Sound is vibration. Unwanted vibrations are those other than the direct airborne sound waves from the speakers of the recorded signals. And that can include reflections, appliances, footfalls, electrical noise, plumbing, outside noise, resonances, buzzes and rattles, etc. Vibrations can also be caused by mechanical and electrical interference. So a neutral environment is our goal. The foundation is our reference for making value judgments, right? So if it is skewed, if the environment's acoustically skewed, so are our judgments. And if it is skewed, so is our experience, or rather our experience is going to be limited. So this is your average listening room versus the desired. So we'll go through these step by step. The average listening room noise floor, ambient noise floor, meaning the HVAC is on, all the equipment is on. You're talking about a 40 dB SPL A-weighted. Ideally, we would like to get down to about 18 dB. So that's a significant increase. So dynamic range, low level detail, that's being buried in the typical audio room. Dynamic range, 60 dB on average, and achievable without, well, I mean, it can be expensive, and of course, everyone's ambient noise floor is different, but chiefly we can get to 82 dB. That's a significant increase, right? 22 dB, that's huge. Reverberation times, typically they'll vary by more than a second across the audio bandwidth. And we would like them to be controlled by less than 0.4 seconds across the audio bandwidth. And we'll go into that further. Room modes, typically you're going to see swings of 25, even 30 dB of, with the room modes. And we would like to, they're going to exist. It's a contained environment. We can't get rid of that, but we can control them without too much trouble, typically down to making them about plus or minus 5 dB. Vibration isolation, and this is a big one, and we'll talk about more of it too. And I think kind of a new topic for for audiophiles. The typical audiophile isn't dealing with it at all. And ideally, we would like to mitigate 90% of it anyway. So what can we expect under such conditions? Well, with noise floor, we're going to be limited our dynamic range. We're going to be masking low level resolution, and we're going to be experiencing distractions that might be, again, like we heard, footfalls or the plumbing or the HVAC turning on or off. It's sometimes the HVAC is on, we're not even realizing it. We're totally in the zone, and then it turns off and we go, reverberation times, again, masking of low level details, limited dynamic range, and poor intelligibility. We're going to go into that a little bit further too. Room modes, discussed those already. Nonlinear bass response and inarticulation. Not sure if that's actually a word, but I'm going for it. Mechanical isolation. Everything in the room has resonances, especially, for example, the big ones are going to be your structural resonances. In the US, in our typical 2x4 with layer of sheetrock construction, if you go in between the joists and the studs rather, and give a light fist bump with 2x4, 8-foot ceilings, that airspace, you're talking about 70 hertz. You're going to hear that play back. It'll play back in sympathy, and later in time, anytime you play back music that has 70 hertz in it, which is pretty much any music that you might play back. And what's interesting is that resonance is the wall takes that energy and it stores it for a bit. It acts like a capacitor, really. So it takes that energy, stores it for a little bit, and then releases it later after the original event has stopped. So not only does your room drone at, say, 70 hertz, or whatever the issue is, but it does so later in time after the original event has stopped. What's interesting also about mechanical structural is that the denser the material that the vibration is transferring through, the further and the faster it moves. So let's say it could be a concrete floor, it could be a wood floor, it doesn't matter. When we play music and our speakers are coupled to, let's say, the floor, the first thing that arrives to us, and this is going to be through our chair and through our butt and through bone conduction, is the structural, in other words, I guess you'd say pre-delay. That's the first arrival time. The second arrival time is the direct airborne sound from the speakers to our ears. And then the third is the structure returning energy later in time. So with isolation, you have a lot of information that is unwanted being mitigated. Very few people have experienced that, and it's quite. I mean, it as we'll see, it hits every sonic attribute in a pretty significant way. So mechanical isolation also will get rid of buzzes and rattles that might be in the room, and even tracking errors of a turntable or a CD, even tube electronics, they're microphonic. You can go on and on. There's a lot of it, even connections benefit from vibrations being mitigated. So under such conditions, can we expect to hear subtle equipment changes? Can we expect to make bare assessments? Might we be compensating for system anomalies? And those anomalies might be the room modes, the resonances, noise floor, reverberation. I've been to many reviewers' environments to help them with their acoustics. And so then after doing so, I know, how their room performs. And so then when I read reviews, I can kind of read in between the lines and have a much better understanding of what they're hearing, because I know of I know what their environment is contributing to the fidelity. So the acoustical objectives are going to be to make the room sonically disappear in the playback system and control the influence of structure-borne and airborne sound vibrations. So the problems: in a small contained environment, sound waves propagate through the space at the mercy of the size, shape, the construction materials and methods, furnishings, etc. Every object will resonate, reflect, absorb, and transmit energy. Most of the energy is returned back into the listening space. In a typical environment, most of the sound you hear is returned energy. In addition, there is a considerable percentage of audible sound sources that are unrelated to the playback recording. So solutions: newer methods of acoustic measurements, and boy, have we come a long way since, really since about 1980. You know, we've got measurement tools available to us that have really excelled. But prior to that, so in other words, not long ago at all, we had very little to work with as far as acoustic measurements for our application. Modeling too, computer modeling, and even acoustic treatments are available that offer means of controlling sound waves in an organized, controlled fashion that's predictable. That's a key word right there. If we understand how sound is propagating in an environment and the materials that make up the environment, then we can begin to understand how to control it. So the results are an elevated and superior audio experience that better represents the artist's intent. And that's the goal of us, right? That's what we're after. We want to get closer to the artist's intent and get the most out of our investment, have the most fun, enjoy it to the maximum capability. Now, this slide's a bit busy, and I don't really want you to break it apart. But for example, the perforated or dotted box, those are all pretty expensive things to do. Down below that, these are things that the typical audiophile can address. So you're looking at the acoustic control in the left column, the control measures in the middle, and the control benefit on the right. And so speaker listener positions, for example, we're going to control that with the room locations, listen to bass response, speaker toe in, speaker angles. That's going to benefit soundstage and timbre. First order reflections, we're going to address that with absorption or diffusion, and that's going to help with spatiality and timbre. Reverberation times, we're going to address that with absorption, and that's going to help with resolution and dynamics. And the big one that I want to talk about here, and this is new probably to a lot of people, is loudspeaker structural vibration transfer of resonances, rattles, buzzes, and pre-echoes. And this is done with mechanical isolation. We're talking about decoupling. We are not talking about coupling. And this affects all the sound quality attributes: articulation, soundstage, resolution, dynamics, spatiality, and timbre. So this, I thought this would be of interest if we have, let's say, any of these issues can be addressed in a scientific manner. And for example, with a noise solution strategy, this is how you go about it. So the first step is we're going to evaluate the noise environment under the existing or the expected conditions. And that means we're going to understand the means of each noise path in terms of octave band sound levels. We're going to measure or model the sound energy levels, spectra, contribution of each path, and we're going to measure or model the total noise octave band spectrum at the receiver location. Step 2, determine the acceptable noise level or criterion at the receiver location. Step 3, obtain the difference between the noise energy in step 1C and step 2. 4, prioritize each noise path contribution in regards to the goal. 5, establish physical, budgetary, decor, local code, and resource constraints. And finally, evaluate various design material solutions that will meet the objective goals. So again, when we're talking about organizing from chaotic sound, there's this there's a step, there's a procedure that you need to follow. This is an idea of noise control and the various applications that can be applied. Let's say we've got a noisy appliance. In this case, this is a copier. There's a lot of things that we can do to address that noisy copier for the receiver to benefit from. We can, number one is we can line it with a partial enclosure. We can get a quiet copier, of course. We can include duct absorption material, sound absorption around the room. We can put up a partition, an acoustic barrier. We can add white noise. We can incorporate structural breaks for isolation of vibration. We can even include earplugs. So and then typically we're going to address this in a number of ways. And the whole idea is to discover what ways are going to benefit most. So here's our typical dynamic range in a typical residence. We talked earlier about 40 dB SPL. So in the dark blue, you see that there's an area where all that information below, covering it below 40 dB is masked. That area is masked by the typical noise floor. That's a lot of low-level detail. That's a lot of information that is there, but we are not hearing. So we are hearing about 60 dB of dynamic range, and we could be hearing 82 dB of dynamic range. That's a lot more amplification power, right? That's a lot more information. Percentage-wise, it's a lot more information than we're getting. Be interesting to kind of figure that out. I'd say it's probably about 50% of the information we're missing because we're covering it up with our ambient noise floor. This is what is called a noise criteria curve. And this is a measurement that we do in residence where we have the HVAC on, we have the equipment on. In other words, normal ambient. Now, this particular customer had an existing NC25 rather than what we just saw in the slide would be more like an NC40. We were able to improve it by various means down to an NC20. So we got a 5 dB increase there. And of course, you always want to look at these curves. So in other words, you want to see the level over frequency, so you know what you're referring to, not just a single number. In acoustics, we're always dealing with single numbers, and that really doesn't give you the information. You have to look at curves. So with this 5 dB increase, if you think about it, we more than doubled the guy's amplifier capabilities, right? That's pretty huge. That's pretty significant. This slide is kind of arbitrary, but I put together this because I thought it would just be of interest. It's, how we were talking about reverberation times are as unique as our voice or signature or thumbprint. Everybody's room has a different reverberation time unless it's under control. Well, I took 50 rooms, and this is your average. So of those 50, and these were media rooms that then we addressed. So this is before acoustic treatment. This is what we were dealing with. And you can see they're terrible. They're totally out of control. To the point where if I said, for example, this is about speech intelligibility. If I said the word bat or bath or bad or, anything similar to that, where the consonant is covered up by the reverberation times, it's very hard to understand what was said. If we can control the reverberation times, then that consonant is no longer masked and we can hear it. So that's just kind of a graphical explanation of what I've been talking about as far as masking information. And this is when we do reverberation times in a room, you typically will do multiple measurements in multiple locations. Like for example, in this, I know in this particular one, there were 9 reverberation locations in the room. You take them so that you're getting out of room modes and you're getting more of an average of the room. And including that would be the critical listening, the primary listening seat. You can see now this room, it has a general, curve, and it's crazy, right? It's out of control. And you can also see it's different at each of the 9 locations. Now, the graph below is after we treated the room. They are the exacts, and each of these 9 locations is going to be measured at least 3 times minimum to get an average. Down below are the same locations, the same room now treated, and you can see now it's under control. It's where we want it. You can see a little tail in the low frequencies, and this is desirable in an anechoic. This is just a psychoacoustic deal. At Owens Corning, I often had to give little tours to VIPs talking about the research that we were performing. And we had a fully anechoic chamber. And there are many people that walk into such an environment and they get sick to their stomach quick and can't stand it and have to leave. The reason is that what their eyes and what their ears see do not correlate. They're not used to it. And it's confusing to the point where they get sick to their stomach. What's interesting is that when we put on headphones or when we're outside, we're talking about anechoic environments, and we don't experience that. But when we have an experience, when we have a memory experience of what the room we're looking at should sound like, and it's not sounding like it should, it doesn't correlate, it confuses us to the point where we have an emotional response. So to have a little bit extra decay time in the low frequencies can definitely be to our advantage. And how much those are, again, it's going to depend on the size of the space, and we want them to be controlled. Another point to talk about is, now this is a different room. If you look at the yellow curve, hopefully you can see that. That was the room. This is a real room that had carpet and furnishings. So again, the reverberation times are out of control. The red line that you see there was me trying to treat this as best as possible. In other words, optimizing 1-inch fiberglass panels. Now, 1 or 2-inch fiberglass panels are only going to be effective down to about 500 hertz. And what typically happens is we'll end up over absorbing from 500 and up, and we are not touching 500 and down. So in other words, we're over treating the top half of the keyboard and we're not touching the lower half of the keyboard. Now, the green curve is showing our FRP system, our frequency response panel system. And it's right in line with where we want it. So it's a controlled environment. This is another test that's called the music articulation test tone, and it's a 1/16th of a second. It's a gated sweep, 1/16th of a second on, 1/16th of a second on. And I just took this particular area from about 500 to 600 hertz because it showed. So when you're listening to it, it goes do, 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 do. And when it is before treatment, in other words, in the red graph, it would sound more like it would slur. And so with treatment, you can see that it's very articulate. The frequency starts and stops quick. So this is our equipment vibration protectors, and this is done in a lab. So the only thing that is being tested is the device itself. There's nothing else in the system. It's not on a resting platform or anything else. The accelerometer is right below the device under test, and it's hit with an impulse hammer. Below is an aluminum cone. And what I want to point out here is that when we're talking about something that is solid, something that is rigid, we are talking about coupling, and we are going to be introducing resonances. So for example, you may find that a solid such device under the, as a footer under your equipment sounds different, and you're correct, and it will sound different every single time if it's not isolating and if it's not decoupling and rather coupling. Every device is going to have resonances where it will exaggerate, it will amplify frequencies, and those are very audible. So every rigid foot under every different load, under every different resting platform is going to perform differently and sound different. And again, not what we want. We want neutrality. So when we are in an environment where we are coupling to the floor, it goes to the entire structure because the entire structure is hard fastened. And so it resonates and plays back, and it can even bother other people. When we isolate, as you can see with decouplers under the source of vibration, then the rest of the structure is not vibrating. So from acoustical upgrades, one, speaker and listener locations are free. We can get the bass optimized, and then we can work on the sound stage and the timbre by positioning ourselves and our speakers optimally inside the room. Isolating the speakers, I'd say, would be the second benefit, the second biggest benefit. Moderate costs. It's going to isolate the structure. It quiets the room from cavity resonances, buzzes, and rattles, and improves articulation and all attributes. And as a side benefit, it will not annoy people. You might have somebody trying to sleep above or study or whatever. The structure is not going to be transmitting those low frequencies to them. Acoustic treatments can be inexpensive to expensive, and ideally you want to control the first order reflections, and that's going to simultaneously control reverberation times, but then you're going to want to work on getting the rest of the reverberation times under control. And then structural treatments, these are going to be more expensive, and this is more about material methods and materials and dimensions of the structure and how they address room modes and or sound transmission. So it's also going to affect how noise infiltrates or escapes from the environment. So now we'll talk about electrical fundamentals and the average room versus the desired. Ground resistance. The NEC allows 25 ohms, but typically, especially with older places, I wonder if I'm too dark. There, that's probably an advantage. Older construction and so forth, you rarely see 25 ohms. It's usually higher than that. And we would like to have 5 ohms or less. Peak current capability. We'll typically, and again, this is actually really conservative, less than 500 amps. Less than 400 amps is more what I see. And we would like to have more than 1,000. Voltage distortion, more than 10%. We'd like to see less than 5. Common mode distortion, more than 2 volts. Typically, we want to have less than 10 millivolts. Normal mode noise, more than 4 volts. And typically, we would like to have, or rather typically, more than 4 volts. And we would like to have less than 50 millivolts. Harmonic content, it's all over the place. We would like to have less than 3% at the third harmonic and really nothing above that. Electrical isolation, we typically don't have any at all, and we would like to incorporate all that's possible. So electrical issues can vary from introducing audible hiss, buzz, hum, and or other interference type noises, to introducing anomalies that limit performance of the equipment, even causing errors or damage. Some of these are less obvious, but more common issues with poor quality AC manifests itself as the sound sounding flat and thin, edgy, harsh, etc. And again, a lot of people have never experienced anything but, so they don't know the potential of what their equipment is actually capable of doing. So again, under such conditions, can we expect to hear subtle equipment changes? You know, if I make a change to, I don't know, an interconnect or something, might not be able to hear the difference because other things are in the way. Can we expect to make a fair assessment? No. Might we be compensating for system anomalies? Yeah. So electrical objectives, we want to minimize the potential to ground. We want to maximize the current delivery. We want to minimize power factor error and K-factor issues, minimize line coupled EMI and RFI noise, minimize field coupled EMI and RFI noise, isolate critical components from the main service and from each other, and provide optimum safety for personnel and equipment. So the problems, again, newer test and measurement equipment reveal problems previously undetected. Many of the old methods of grounding, bonding, and shielding are unreliable, especially with today's sensitive digital equipment, and cause noise, glitches, errors, loss of information, and even damage. The trend of lower voltage circuitry with higher density integrated circuits and more RAM is increasing, and increasing clock speed will continue. So it's more critical as technology marches on. The solution, there are newer methods of AC grounding, filtration, isolation, bonding, and shielding that will improve safety as well as the audio equipment performance, reliability, and longevity. So the results, along with the safety and equipment improvements, the end user will experience greater dynamics, speed, resolution, and imaging in both the audio and the video presentation. What are some general electrical recommendations? In general, you want to oversize everything. And another thing I want to stress is don't condition unless it's required. We have so many, line conditioners, power conditioners that are bought, and you just want to be careful there. You don't want to be buying filters that you don't need. Filters on top of filters are not a good thing. Ideally, we want to have a very pure system, and one that has anything that's unnecessary removed. So caution as far as buying just any old power conditioner, and they're all different. They all do different things, and they do different things in different ways. And we just want to be careful that we aren't getting things that we actually don't want. We want to address the issue that we have and nothing else. So again, overrate everything. So heavier cables, circuit breakers, all that kind of thing. Clean any visible corrosion or carbon deposits on the grounding rod junction, bus bars, breakers. Replace if old or has tripped many times, or outlets. Gas tighten or exothermically weld all the connections where you can. The grounding rod, those connections should certainly be exothermically welded. And try and avoid other AC and signal cables by about 5 feet, and try and cross it at right angles, and isolate when you can. This is something that's usually free and easy to do, and can have a huge impact on the performance. So in summary, good signal integrity means flowing unimpeded throughout the chain. And the 3 ingredients for this recipe are quality materials, large, smooth, clean, dry contact surface areas, and tight connections. So here's some real examples. This is measured at the grounding electrode, and this is the resistance of a before and after. So this at this residence, I measured 142 ohms. Now, if you remember, the NEC wants to see 25. With sensitive electronics, we want to see 5 or less. So after treatment, we ended up with 0.53 ohms. And that treatment there, that was just, we added 2 more technical ground rods to his existing. So that's all that it took. It was not expensive. In this instance, we've got voltage harmonics, and you can see many of them on the left-hand side. And on the right side, you don't see really anything, a little bit on the third harmonic. And here what we did was we improved the quality and the configuration of his circuits and isolated it from his existing panel. Again, not an expensive upgrade. And here, now this, we added an isolation transformer, a balanced, separately derived system. And so here's common mode noise before and after, 6.3 millivolts versus 0.001. So cleaned that up considerably. And common mode noise is pretty common, again, especially with the newer technologies, and can be problematic. So regarding electrical upgrades, ground resistance, often less than $1,000. Lower the impedance means less reflected noise in the system. New cabling, moderate to expensive. Quality wire configurations and connections mean less interference, less resistivity, and better impedance matching. And then stepping up to an isolation transformer, you're looking, depending on your system, 10 to 20K. A separately derived system means dedicated clean power, and you're no longer subjected to the grid. So we're almost at the end here. This slide is showing you what I call the playback priority pyramid. And so on the bottom of this pyramid, you're preparing the ground, and you're doing that by controlling the physical noises and vibrations and electrical noises. Then building on top of that is your foundation. You're going to optimize physical layout, your room listener speakers for best bass and imaging. You're going to make sure your equipment is operating to specification and it is properly calibrated. Again, going back to optimizing the speaker listener positions, if you've got just a portable boom box and you're off to the side of it, you're not going to hear stereo. You're not going to have much of an image. So it's critical that we get these steps in order. Then optimizing acoustic treatments for rim modes and first order reflections and reverberation times. Now we can start tweaking. Now we can start isolating other components, not just the source, not just the speakers or subwoofers, but the electronics. And we can start isolating the electrical fields as well. Now we can start looking at upgrading the equipment. Now what we have is a neutral controlled environment. And so now we can feel confident with what we subjectively hear as a change is a true change, and not just that is a true improvement and not just a difference in sound. So the takeaways on this presentation are: there are fundamental sound quality attributes which are known and measurable. The typical listening room is pretty far from ideal, which lowers the performance of the equipment and the experience for the listener. There's a hierarchy to achieving sound quality. Coarse changes are required before fine-tuning can be perceived. Only a neutral environment can offer a fair playing field. And the biggest obstacles are often the smallest costs. So as Mark mentioned, go to this website, and there's many articles and videos that'll get into more details of this general presentation. And it also has our available products and services for these solutions. So that's it. Thank you. And now we will open it up to any questions, and I will stop sharing.
That probably opened up a lot of questions because there was a lot of stuff in there.
Yeah.
Who's up? Bob Fennerin, you're first. You want to unmute and ask away?
Yeah, Bob Fenner, and thank you very much for an outstanding presentation.
Thank you.
My question deals with something you haven't addressed, and that is relative humidity. My site varies from 20% up to 80% as the year progresses. Can you address any of that, please?
Yeah, humidity, as far as, for example, absorption characteristics in materials, plays an important factor. And you're right. For example, when we test materials, we record the humidity, and hopefully the lab has it under control. So usually you'll find in labs they're enclosed, hard, concrete environments, and they can sweat. And so you have dehumidifiers running all the time, except for during a test. But yes, temperature and as well as humidity does play a role on how we hear things. In temperature to a less extreme in a small space, but humidity definitely plays a role. And so those of us who are in very humid conditions, I would suggest, if you have a dedicated space, that you incorporate a dehumidifier, such as I do. In Columbus here, it gets humid, and so I have a dehumidifier, and I run that on automatic and turn it off when I'm running tests or when I'm listening to music.
Thanks, Bob. John Bratton, you want to unmute and ask your question?
Yeah, Mark, thanks. Norm, thank you very much. This has been great. I've got two questions. The first one deals with not so much the electrical, but the acoustic treatments and isolation. This is a very crowded space. And I mean this question most respectfully. Why you and not HRS, critical mass, GIK, isoacoustics, Wilson pedestals, or whatever? And I've got one more question.
Oh, why? I'm not sure I understand the question. Why what again?
Why AV Room, why your company, and not everyone else and his brother that's in this space?
Okay, well, so the way I would answer this is I mean, there's a whole lot of talking about our equipment vibration protectors, that particular product. There's a lot of competition out there, but I would say that most of them are not isolators. They are not decoupling. They are coupling, and this is a big one just in our let's say audiophile world. This is not something that is misunderstood in the noise and vibration world, or even the pro audio world. You do not find couplers under vibration sources like speakers or subwoofers. Why this is, I've got ideas as to why that is. I think that it started out with couplers, and people went, oh, this sounds different. And remember I showed you a graph that shows how every different coupler is going to have different resonances in the audible range. And so those peaks they're amplifying the sound. So when we put them under our equipment, it's louder. And us audiophiles, I think in general, have the feeling that if it's louder, and I haven't changed my volume control or anything, it must be better. But it is not. It's only different. As a matter of fact, it's not accurate, and nor is it predictable or repeatable. The equipment vibration protectors are. They're neutral, they're predictable, they're repeatable, no matter what other variable is introduced in the system. Now, the other thing that I want to point out is that any acoustical product should be third party through an accredited acoustic lab. There's standard tests for this. They should all be published. All of our acoustical products are published on the website and available for you to see. I don't know of a single competitor as far as an isolation product in the audiophile world that publishes their results, and that should be suspect. It's not right. It shouldn't be occurring, and that's something that that I just don't understand.
Okay, and that's fine. I appreciate that. My second and last question is, and I know it varies depending upon size of room, and there's all kinds of variables and stuff, but you've done a lot of this. Rule of thumb, any of us that wanted to take you up on what you did here, maybe exclusive of the electrical stuff, room treatments, reverberation times, whatever, what should we be budgeting for something like this?
Tough question, John. It depends on the depends on the space, obviously. Depends on the size of the space. Depends on so many factors.
I would guess that most of us have bedroom size things going on. We don't have ballrooms, you know. So
Yeah.
I mean, just I mean, is this a 4,000? Is this 20,000? Is this 50,000? What are we talking about here?
It is a really tough question, and I'm happy to help people do things that are inexpensive, like you know, I mean, area rugs or bookcases or large leaf plants as diffusers. There are curtains. There's a lot of things that can be done that are inexpensive that are going to help a lot. It just depends on how much control you want, how bad the situation is. Obviously, the surface area that we're needing to address, and the frequencies. The smaller the room, then yeah, as far as mids and highs, cheaper to address, but as far as lows, more and more difficult.
Norm answered earlier when Bob was asking about high humidity. In the wintertime, you typically have low humidity down to like 10 or 20% and a lot of static issues. How would you address that, Norm?
Well, there you're talking about electrical issues, and especially regarding electromagnetic fields around cables, AC cables, power supplies, signal cables. And so rather than an acoustic issue, now we're talking about an electrical issue. And we do offer a product that does address that, called the cable vibration protectors. They do mechanical isolation, and then cables that are on the floor, you know, like for loudspeakers or maybe interconnect, the jacket acts as an electromagnetic coupler. When you take, and this is on the website, there's a video, and it shows a device that measures the static electricity. And if I take the cable and lift it off the ground, off of the ground, you can see that the static charge goes up. If I put it back on the ground, it's coupled. It now goes to 0. So we want to address the mechanical, and we don't want that. You know, how perceptual that interference is, I haven't any idea, but I know it's not good. So anyway, we have a product that addresses that. We also have a product that has a jacket that does just the opposite. So now it is a mechanical and electromagnetic isolator. So you can use it behind interconnects, like behind your preamp, where you've got maybe a power cord, or maybe you're trying to isolate digital from analog, or maybe even just right and left.
All right, thank you. Arnie Balgalvis, go ahead.
Yeah, hi, Arnie Balgalvis. What is a typical visit to someone's listening room to evaluate, just to get down to the basics of what is, shall we say, what is the current situation in a room, so that one can decide what measures to take?
Right, yeah. So an on-site visit is about $4,000, and that comes with a report. But there is an awful lot that I can do just from photographs of the room. So, you know, you can you can private message me and tell me what the problem is in your mind, if you've got a particular issue, and I can tell so much just from a few photographs. So usually that's where I start, and then I'll often send you a questionnaire. And what I'm trying to do is determine what are the sonic issues that you think you are dealing with, and maybe to what extent, and maybe learning how to address those issues before coming out there. So sometimes I can help you out without coming out on site. Obviously, coming out on site with test instruments is the best. But nowadays, there are even some things I can tell you to do to help me evaluate without coming out there.
Thank you. So Steve, go ahead.
You mean me?
Yes.
I
Somebody was
wanna-
ahead of you, but
I just want to thank the gentleman who we're all talking about, Norm, because I have a system that I decided at one point to add a couple of subwoofers into at the recommendation of a dealer. And I understood what it was likely to affect, but I had the unintended situation of causing a lot of vibrations in the room. And then I learned from Steve Sharp, who's a member of our group and a writer for TAS, to look into Norm's products. And I put a pair, I should say, 2 sets of 4 EVPs under my subs. And lo and behold, suddenly the room was quieter again, more accessible, more. And then I said, I'll put those upstairs under my, Rebel salons and my sub, my SVS sub. And sure enough, everything was tamed. And so all I can say is that the stuff works, it's important. And even beyond that, we often don't know what our problems are until they go away. And so that's part of the challenge that we all have, is trying to figure out, well, can I make an improvement? What does it sound good to me? Otherwise, we are in this process of chasing after something, and we're not sure what it is that we're chasing after. So it's just more of a thumbs up for Norm's work.
Thank you very much, Steve. And, I would say that, any system, regardless of cost, will benefit from the EVPs. So, and again, as I mentioned in the presentation, they will address every sonic attribute. So in my, decades of experience, that's the biggest bang for the buck. Isolate your speakers.
Gary, you were the guy that we screwed by lowering your hand. So go ahead. Sorry about that.
All right, thank you. The room that you see behind me here is like 21 wide by 35 long.
Nice.
And I kind of built the home around this room when I moved to Florida. I thought I was big stuff when I had them put 4 20 amp lines in to the electronics room, which is adjacent to this room. But that's all I do to do. They're just ordinary 20 amp lines with no fancy ground resistance, 25 ohms to 5 ohms. I don't know what that's all about. How do you measure that, and who should I call?
Well, so what you've done is you've got some dedicated circuits going to the room, but they are not isolated from your panel nor from the grid. Nor are they, maybe high quality or as heavy gauge and the right configuration, the right wire, in other words, the right installation and all of that. So you've done like the minimum step, and it's a step. That's a good thing. I would suggest, Gary, that the next thing you look at, and the next affordable thing that you could do anyway, is look at the ground impedance. And what we're talking about is measuring the grounding electrode. In other words, the grounding electrode conductor that is connected to the rod, the grounding rod, and your bus going to your panel. I don't know, obviously I can do it, but probably it will take some effort on your part to find a local electrician that has the means of measuring that. It doesn't seem to be very common. But that's what I would pursue first, is see if you can get that measurement. And again, I'm happy to help you in any way I can. And then once you find that measurement, the next thing that you look at, Gary, is, okay, so what kind of soil is Gary on? What might we need to do? And I can tell you at minimum, we're going to be looking at what they call a technical ground rod system. And that is, we're going to put, we're going to wrap it with Benadite, and so that it does a better job of conducting the rod to the earth for a much longer period of time. So anyway, that's a pretty that's something that most anyone can benefit from pretty affordably. It's another one that I recommend. It's like the first thing that I would do as far as stepping up your electrical. Easy and significant.
I have an electrician friend that I work with, and I just didn't know what to ask him if he could do. So
Ask him if he has a clamp that he can measure the grounding electrode conductor.
Okay. And I have a hum and buzz problem. Are there Band-Aids for that?
I don't like Band-Aids. No, you want to fix what the problem is. You want to find out what's causing that. There shouldn't be any. So yeah, you want to find out what that is. You don't want to filter it out. You want to eliminate it.
Okay, thank you.
Mm-hmm.
All right. There are a few people in the chat that don't have hands that have been waiting over there patiently for me to call on them. So before I get to Bob Fenneran's second question, I want to get to a couple of people in the chat. Jeff, Kalina, you have like a bunch of questions. Do you think you can narrow it down to one or two?
Yeah, I'll just pick one of these things. By the way, thank you for that presentation. That was really insightful. I think the one that I'm going to go with is my first one. I have a balanced power transformer that I'm using. It wasn't super expensive. I bought it, I think it was $600. Might have cost to have that much to ship it. So what's your feeling on these? I mean, I've heard bad things about conditioners in general, but I thought maybe this type was safe.
Who makes this balanced?
It's made by a guy who's, I think he's dying. He's closed his company down. I think he was in the Midwest. He was a friend of a friend.
Okay, so nothing that I would know about.
Probably not unless you've been following these things for the last 20 years, which you probably have been.
I have.
Yeah. Okay. So I wish I could tell you the name of the guy, but I don't have it handy.
Okay.
But it
or
has
the
about a
brand?
60-pound transformer. Yeah. BPT, Balanced Power Transformer. Their products are still around.
Huh. Okay.
You get the
Yeah.
last one.
I don't know it, but in general, I am a fan of balanced transformers. So, and again, beyond that, I have no idea what you're dealing with.
Sure.
So, yeah.
It's something about balancing the charge on each pole.
Right.
I'm not
Yeah.
very technically oriented, so I have no idea, but that.
Well,
is
you
that-
probably understand XLR cables, right? Those are balanced. So it's kind of the same application, same idea. I'm a fan of, there's a couple of brands that we handle, Equitech and Taurus. Both of those are balanced audio transformers. In particular, those are, and like I imagine yours is, they're specifically designed for audio equipment.
Right. Yeah, absolutely. That's mine. Mine is designed that way. So you're saying I don't need to be worried about, well, you're not saying really, you don't know what I have, but.
No.
Okay.
No,
Yeah.
I don't know what you have, nor do I know your power conditions, your power quality at all. But I'd say you're on the right track. You can't do any harm with that, whether it's addressing a particular issue that you have. I have no idea.
Yeah. Well, I think I have pretty good power because I'm near a transformer and I have 220 amp dedicated lines coming in here. Let me ask you a quick question. Do you ever take your stereo outside and listen to it and then compare it inside to outside?
No.
No.
But I have done what you're talking about, but I would not be able to do that very easily with my system.
Okay. Yeah, it's a little difficult. I've rolled my speakers out, but the difference in the sound quality it more than doubled. And I have a fairly decent sounding room, or so I've been told. But going outside was like a whole new world. It was amazing.
Well, if that's the case, Jeff, I'm thinking that you probably could do some more work on the acoustics.
Okay. Yeah.
Okay, thanks for the question, Jeff. I want to move on to the other people. Before I get to the raised hands, just one other thing. I see that Tracy Sakai asked about the PS Audio power plant. Doug Coffey asked about the AudioQuest Niagara power conditioner. I know Arnie Balgalvis compared them and actually wrote a review. I think it came out, Arnie, if I remember, that you kind of liked the Audio Quest slightly better, but you both thought they improved your system. So, Norman, what do you think about those kind of things? I use a hospital grade isolation transformer just on my digital sources and computer.
Well, what I was mentioning before is, there's a difference between an isolation transformer and a power conditioner. Power conditioners are going to be addressing they will possibly be addressing many different issues in different ways and at different levels. And so when you compare one in this environment that may need these, meet these conditions, but not the others, or this environment over here, it's a hodgepodge. It's really hard. A good quality isolation transformer, that's going to give you a good clean break from the grid. And, so now you've got a good clean energy source, and hopefully you won't need to do any other conditioning. If so, then it's probably at the fault of a piece of equipment. Mm-hmm. But my thing is that those conditioners can be great. They can also be bad. If we're applying one to something we shouldn't, then it's going to have some negative qualities to it. Mm-hmm. So that's again why I say it's important to understand. You need to measure the equipment and apply a proper solution.
Gary Reber, I don't think you've asked the question yet. Do you want to go ahead?
Yeah, I can highly recommend Norm. We worked together many years on 2 widescreen review reference systems.
Yep.
And the biggest improvements that I have found is in the balanced power transformers. It's just night and day. I've used the Equitech wall system, which is a big wall system, fully 20 amp system.
Yeah,
and
it's
currently
about 400 pounds.
Yeah, right. And currently in my living room system, I'm using the Equitech 5, I credited in the magazine something. 5Q.
Yeah,
5Q. Right. And it works fantastic. And that's an affordable power condition that I recommend to everybody. And definitely plug your power amplifiers into it also.
Yeah.
You won't hear anything. I can't hear anything. I can have my system on and I can walk up to my big magnepans. I don't know if they're on. You cannot hear anything. It's just noise free, and it's just fantastic.
Yeah.
So, but Norm does a great job on all this stuff.
Thank you, Gary.
Thanks, Gary. And one thing that came up about the question about the ground. Do you think you could send me or put in the chat at some point the specific questions to ask an electrician, so, like in terms of what they need to know and what they can do?
Yeah, I could. Now, in the slide presentation, I hit on that pretty well. When I go out and do an on-site survey of the electrical, there's 20 something, maybe like 30 measurements that I take. So yeah, I mean, there's quite a few, but there's some basic things that I think, again, the average electrician, just like, the average acoustician, may not have the understanding or the equipment to take the measurements that are important. They can take some basic measurements, but maybe not the ones that we really need. But anyway, I'll send you that, and there are electricians out there that can. You just got to do a little sleuthing.
Okay. All right. Let's see. Somebody else who hasn't asked yet. JR Boys Claire.
Hey, JR.
Hello.
Good to see you.
Hi,
Good to see you, by the way.
Good to see you all. I wanted to put a quick plug in for Norman. He is, I've certainly learned a lot from him, and we're really kindred spirits in that we both are fully aware that there are some things that can be measured and should be measured in order to get the basics right. And he and I shared a trade show booth together. We're going to do it again in Seattle. And I just enjoy being, just picking this fella's mind. I've learned a great deal from him. And he's not one of he's not one of those guys, if he doesn't know, he'll say so. And he's not, beware of people who know everything in this hobby. I mean, if the people who really know a lot are learning so quickly, in my opinion, that they only are realizing how much more there is to learn.
That's
So,
yes.
yeah.
Yeah.
So, yeah, I can, so more of a comment than a question, but I just want to say, Norman, I love what you do and certainly support it.
Well, back at you, JR. Thank you very much.
All right.
Hey, Norman, can we expect to see you at the Capitol Audio Fest this year? A lot of people on the East Coast go to that.
Yeah, I'll be there. And as JR just mentioned, we're going to be at the Pacific Audio Fest later this month, next week, I guess.
That's right.
Yeah.
Norm, great presentation. I gotta go.
Okay. Will I see you at CEDIA, Gary?
No, I'm not going to CDS yet.
Okay. All right. Well, I will be there if anybody else is going to be there.
I know. Yeah,
Okay.
yeah. It's great.
See you, Gary.
Hey, thanks so much. All right. Thank you, everybody.
All right, thanks, Gary. Now we'll get back to repeat questioners. Bob Finneran, go ahead.
Great presentation, as I said before. Have you ever had to address a room that had a grand piano in it?
Yeah. Yeah, two things that pop up to mind. Yes, absolutely, I have. The first thing that I would do is lay a blanket over the strings. And then the second thing, that'll help from your point of view of listening to music and not causing it to excite and play into the room. And then the other thing is from a performer's point of view, put EVPs under the legs. We have done this numerous times, and professional pianists have then said, not only does it sound better, much more harmonic content, but these two of these guys have said, I can feel it. It feels better, which is really cool. We've been getting that kind of feedback. I play drums, and the first time I discovered it was under my floor tom-tom. I tried it out, and oh my gosh, my floor tom-tom has so much more sound.
Yeah,
so much
I didn't hear what you said.
under my floor tom-tom legs, I put EVPs, and now the floor tom-tom sounds so much fuller and richer. Then Michael Bishop, the recording engineer who passed away last year for Telarc and so forth, he puts EVPs under his microphone stand, and he called me during a session. He was recording a cellist, and he called during a break, and I said, do me a favor and try putting an EVP under the end peg, that connects the cello to the floor. And he called back and he said, I wish we had done the whole session that way. It just allowed the sound to be more harmonic content.
Yeah. I don't have the strength to lift the legs of the piano to do that. So
What is
It's
an
not a
EVP?
one-man job.
What's an EVP? What are you talking about?
Equipment vibration protectors. So a grand piano, you're talking about, depends, 700, 900 pounds. So we make custom EVPs for such things. So we've got, 3 4-inch EVPs, one under each leg, that can handle that kind of weight and isolate it now from the structure. So now the structure doesn't also reflect back. Same with the speaker. It's a two-way street. Vibrations are always a two-way street. So it not only prevents it from transmitting into the structure and exciting it, but from that excited structure reflecting back to the soundboard.
So do you have an EVP under your computer right now for a better sound to the microphone?
Under my little tiny subwoofer, yes.
Oh, you do? Okay.
I do. And that's mainly for noise controlled so it doesn't annoy others.
Okay, all right. So I won't ask you to do an A/B test of removing the EVPs and seeing what.
Right,
Okay,
right.
never mind. Arnie, go ahead.
Yeah. Hi. I just want to mention that the presentation has been fabulous. I learned a lot, and I appreciate to be able to participate.
Thanks, Arnie.
My question is about your system. Would you care to elaborate what the system is?
Sure.
And then
Yeah.
the second thing is, I have the Revel Salon 2 speakers, and the way I sit right now, I am slightly below the tweeter, axis. If I were to use the EVPs, then that would raise the speaker. And by how much would it be raised?
Yeah, you're correct, Arnie. And it would raise about an inch or so. It depends on the amount of compression. Normally, the EVPs are going to compress about 30%, 10 to 30%. And you're right, the elevation, depending on many other variables, and of course the particular speaker, but the elevation will change, and that can change the sound attributes too. And therefore, you might even consider raising your listening chair if need be.
Yeah, well, if it's an inch, I can raise the listening chair easily. Yeah. So
Yeah.
What about your system?
Oh, yeah. So it's a room within a room. It's a dedicated space. All the floors, the ceiling, walls, they're all independent. They're all isolated from one another structurally. They're made, we use all of our products in it, constrained layer damping, our frequency response panel system, the dimensions, everything are the best that they could be given the physical constraints of the space as far as a room mode distribution point of view. So from a noise control point of view and a room mode point of view, it's optimal. The electronics itself, I have what they call, this company doesn't exist anymore. They're booth audio speakers, and I have their aperiodic loaded transmission lines. I have the same speaker right and left, front and back. So I have a 5.1 system. And then I've got a pair of compound loaded subwoofers. And then the center channel is an exact match of the other main speakers minus the woofer. I'm dual mono biamping, all MIT interconnected for the most part. They're Coda technology, same amplifier driving all of the speakers. Speaker lengths and interconnect are all the same. I have a dedicated, SDS, and again, those dedicated circuits are the same lengths. I've got, I'm into analog and digital, so I stream, and I've got over 5,000 LPs. That's anything else you want to know in particular?
Thank you. That's
okay.
Educational.
Norm, I have a couple questions. A real quick one. What type of music do you most like to listen to?
I totally go in moods. So sometimes it's blues or jazz or classical or classic rock. So I listen to anything but rap.
This one's a little bit longer. People have been asking you about their specific systems, and I wanted to ask you some generic questions about acoustical treatments or whatnot in rooms. So I was going to throw a few things at you, and you can either say yes or no, or give a quick explanation.
Okay.
A lot of people have a TV between their speakers. Do you recommend they cover that when they want to do critical listening?
Yeah, that's a good idea, because you do have a reflection point there. Again, it depends on the size of the screen, but every speaker is a source, and it's going to have six. We've got six surfaces in our room at minimum. That each of those speakers is going to have 6 first order reflection points, And so, like I was talking about earlier, one of the first things that you'll do in controlling the propagation of sound in a room is to address those first order reflection points. And you would do that with either absorption or diffusion, depending again on what you need. Sometimes you've got a room that is already very absorbent, and so you don't want to introduce more. And so you would put a diffuser at a first order reflection. Now you're scattering, how you're eliminating that specular reflection, that interference to you, and yet not introducing more absorption into the environment.
What if you have large, picture windows in your listening room? How will you handle that?
Really problematic, but from several points of view. One, they're going to resonate. Two, they're escape routes for low frequencies. That can be a plus. That can help as far as room modes. It can also mean that it's not going to contain the energy. It's going to escape. And then obviously you've got a reflection point. Now, the easiest way to address a window from a reflection point of view is with a curtain.
A lot of people have a coffee table between where they're sitting and where their system is.
Bad idea.
So
Thank you for that.
Critical, move it.
Yeah.
Want to listen.
Oh, well, when you're critically listening, just move it out of the way. But yeah, and again, I'll see this at reviewers' homes quite often and remark about it. You've got that's quite a reflection that's interfering with your evaluation. And so I recommend putting something on it or that's going to absorb that reflection, or moving it aside so that it's out of the way of a first or maybe even a second order reflection. Because yeah, that can be a big interfering factor. It's definitely audible.
If you have doors or multiple doors, keep them open or closed.
Well, again, if most doors are just hollow and don't really do anything. The low frequencies don't really see them anyway. But if they're solid, they are going to contain some of that energy. By opening them, then that's going to relieve room modes. But again, at the same time, you might relieve some of the visceral impact that maybe you're after, which means you got to turn up the volume if you want to enjoy that again. So yeah, it depends. You can take measurements though and find out, is it removing the cue of those room modes beneficially to me? And most likely it is. Again, we're talking small rooms. So to open up a door, it's going to, be a noise control issue for other people, but it will smooth out the room modes. And so most of the time, I would say that is going to be a benefit from a room mode point of view. It also means that opening now is absorption. So it again, depending on your situation, that can be a plus or a minus. But if you open up a window, that's 100% absorption.
Okay, a couple more and I'll be done with this. Carpeting, hardwood or concrete floors, good, bad, or otherwise? How would you rate them?
They're different, but regardless of the floor, you've got a first order reflection point that you want to address. Yeah.
Okay. And that was actually my last question. How do you know where your first order reflection point is in your room? How do you figure out where to put the absorber or the diffuser to know where that point is?
That's a real easy one, but it does take two people. You need an assistant and you need a flat hand mirror. And so you're going to it's just a matter of geometry. I mean, you could also do it mathematically, but the easiest thing and the 100% confirmation is you're at the listening position and you have your assistant go to each of the 6 surfaces. So this means getting on a ladder for the ceiling as well, and locating the tweeter. When you see the tweeter in the centered in the mirror, then take a piece of masking tape and mark it. That's your first order reflection on that surface for that speaker.
Is it normally at the speaker level height or ceiling level height or?
Tweeter, you're looking for the tweeter. So we're really trying to address the high frequencies for sure, and the low ones. The higher the frequency, the more directional. So really what we want to try and nail on a specular reflection point of view is the tweeter in the mid-range.
Okay. All right. Thank you very much. I will get back to some raised hand people. It looks like Gary is next up. Please unmute yourself, Gary.
We've talked about a lot of electrical items, such as the ground rod system, balanced power transformers. Wouldn't it be wonderful if you could publish a picture, a circuit diagram of an audio room with all of these components leading into it, where they are and what they're called? Does that make any sense?
Yeah, it does. All of the stuff that we've covered throughout the years, if you aren't already, then subscribe to my YouTube channel and look at the articles on the website. There's a ton of stuff there. But you're right, and I still do. As things come up in conversation, I create new diagrams or whatever. Specifically, everyone's got a different situation, and so that's why they hire me. But in general, I can do what you have described, and I'll look at doing that again. But if you were to look at some of the articles, and I can't think of specific many posts that I've done on Facebook, on my Facebook, I've hit electrical a lot. Not very recently, but this year.
Okay, I'll look at the website. Thank you.
Okay, Alan Edelstein, go ahead. Edelstein, sorry.
I'm not sure which one's correct. German would be Edelstein.
Right. I want to get it right. Mr. Edelstein, go ahead.
We've talked about isolation of vibration of mechanical devices and putting isolation devices under them. But how about putting isolation devices under electronic equipment to isolate it because of the effect on microphonics? And I ask this because I played with it and heard changes in electronics that sound like I bought a product from a completely different company sometimes.
Yeah, well, of course, we recommend that. There is, again, a priority to do it. So if you're interested in isolation, excuse me, the biggest bang for the buck is to address the source of vibration first. So your subwoofer, your loudspeakers, isolate those. That's going to give you the biggest bang. That's going to quiet the room. That has a huge impact sonically. Next, address the more sensitive electronics first. That would be a turntable, a CD player, a DAC, anything with a digital clock in it, with a quartz crystal is sensitive to vibrations, anything with tubes, because they're microphonic, cables, and so forth. And the way I would do that is, if you can't in your mind already know in my particular system, the most sensitive piece of equipment is this, then I start with the source and work my way down. Because anything down here is going to benefit from what's being addressed up here.
So I've isolated a lot of my electronics, but not my speakers. And what you're saying is I'm fixing a problem caused by something else, right?
Well, yes and no, but you are missing the biggest bang for the buck.
Okay.
Yeah, that's
Thank
speakers, source of vibration. That's the first thing that I recommend.
Let me just ask you a question. When you're dealing with small speakers that are on stands, how do you recommend isolating at the bottom of the stand, or?
Yeah, that's a great question. Yeah, the best thing to do, and you can't always do it this way, but ideally it would be between the speaker cabinet and the stand shelf. That way, any vibrations from the speaker cabinet will not transfer to the stand, which is going to resonate, and to the floor, which is going to resonate, et cetera, and then back, in reverse. So that's the best place to put it in the system is again, you want to isolate it at the source.
All right, Arnie, go ahead.
I have a question about the power line quality from place to place. In my review, I've made a big point about it, that just for example, the power line conditions at my house, I'm willing to bet anything are completely different at the power line conditions now, even before correction, I mean, than they are at your place. So it's like listening rooms. There are no two listening rooms that are the same, and I would say no two. So, you know, that's important. But what I also was asking about, sort of sarcastically in the industry, that is there a device that can be used to analyze the condition of a power line, and then therefore, you know, take some measures to try to correct that?
Yeah. So, you know, to comment on, you know, everybody's power supply, you're right. Everybody, and it varies from not only place to place, but from time to time. So sound quality is unless you've got it under control again, like with a separately derived system, it's going to vary. And just like acoustic, so you do need to measure, you need to investigate and find out what the problems are and address them properly while not addressing other things that should be left alone. Let's see, the second part of your question was what?
Measurement.
Oh yeah, so there's, you know, just like anything, there's several different devices. The Fluke 43B is my main device, but that's limited. It's not going to tell me, it's not going to measure common and normal mode distortion. It's not going to measure ground, and well, it'll measure impedance, but not ground electrode impedance. So yeah, I mean, like anything, there's going to be several devices that are going to be needed to do a full investigation.
Thank you.
Okay, Chris Haar, go ahead.
Thank you. Quick question. Looking at the product page for your EVP platforms, sorry about that. With these are prices for pairs, is that accurate?
No, those are individual. So all the EVPs are individual.
Okay.
Now with the EVP platforms, you need one pair. So you would run a pair under your amplifier or speaker, either running on each side front to back or on the front and back side to side. Where with the regular EVPs, you need one, you need at least three, setting up a tripod setup, or one under each foot, 4, or there are times where you need 5 to handle the load. Sometimes buying 5 2-inch EVPs are going to be cheaper than buying 4 4-inch, and will accommodate the load. It's all about handling the load properly.
Yeah, I understand that.
Overload it or underload it.
Because the amount of compression affects the acoustic property of the damping material. Okay. So for example, I've got Focal Scala Evos. They're about 190 pounds a piece or so, right?
Yeah.
And so given that they're a relatively narrow but also long platform, they're on casters, but they also have spikes. So probably in your solution, you're going to spike the speaker on top of one of your platforms in order to prevent it from moving around. Is that correct? Or
well, so the more affordable would be to put a platform in the front and back, going side to side, because that's going to be a smaller platform and more affordable. If you can eliminate the spikes, I do. For one, we talked about elevation earlier as an issue. And secondly, you want to remove anything in the system that doesn't need to be there that could contribute. Not that the EVPs care about what's above or what's below them, but just understanding that the cabinet's going to cause the spike to resonate. Now that won't be transferred down to the structure, down to the floor, but it will be reflected back to the cabinet. And so that's not a good thing. So I recommend removing it if you can. And if you cannot, as in some instances, then you just use it. And we supply these little like coins, so to protect the surface of the surface of the EVP.
Sure, speakers came with that. I'm not sure if the casters are removable, to be perfectly honest. They're there to allow you to remove them from the boxes and to position them before you come up with a final solution. So I might be stuck in that regard. I noticed that you have different cover materials. Are any of these particularly slick or not in terms of?
Yeah. So we offer typically two, felt or rubber. Felt works well if you like, for example, a preamp on a smooth surface. If you wanted, if you're often getting to the back of it, then a felt EVP is going to slide pretty easily, where rubber is not going to move at all. And so you might want rubber under a speaker, for example, that you don't want to move. The performance is exactly the same between the two. The other difference between movement is height. The rubber is going to be, the top and bottom is going to add a 1/2 inch in height.
Thank you. Okay. I won't take up more of your time on that. I can ask you other questions offline if necessary.
Thanks a lot, Chris. I promised Sam Arar that he would go next because he couldn't find the raise hand gesture. I just wanted to make one quick comment and then I'll call on Sam. I guess a lot of us were resistant to the idea of putting isolation devices under speakers because we thought the stability of the loudspeaker was more important than the isolation. And I take it that's not true.
This could be, this is a deep conversation. And I mean, this is what I love this. But just the short answer is, if that speaker cabinet is made of cast concrete, and I've got a pair of old Rauneteers from Sweden.
Oh, cool. Yeah, I love those.
Yeah. Concrete moves. Some manufacturers even design their cabinets to move as part of the sonics. The EVPs are not going to change that. The cabinet's still going to move. All the EVP is doing is eliminating the transfer of vibration. What was I going to say when you the first part of your
well, the tiptoes or spikes or whatever provide stability.
Oh, yeah.
And the idea that the speaker can move slightly freaks us out.
Yeah. Well, now the EVPs are mainly they're layers of fiberglass. Okay, and they work like leaf springs. And this is, as far as 6 degrees of freedom, this is mainly up and down, okay? So via transmission to and from the resting platform. But the significance, again, from a sonic point of view of isolation, or rather decoupling versus coupling, is huge. And again, as I say, that cabinet is still going to move. The EVPs aren't going to stop that, nor does the manufacturer maybe even want it to. So yeah, it's one of those myths that is misunderstood in the audiophile industry, and I want to put a stop to it.
Yeah, but persistent. But we'll try to stop. Hopefully, we're doing our little part to stop it.
Yeah.
So, Sam Arar, would you like to unmute yourself and ask your question?
Well, thank you so much for a fabulous presentation. I learned a lot. I'm a do-it-yourselfer guy. I build my own speakers. I build the Wilson XVS with a separate compartment, if you will. So I use time alignment to align my stage, if you will. However, I have one problem. You mentioned earlier about maybe 70 hertz, that the room with the speakers, I guess. And I cheated there. Instead of building a filter for it, I end up using an equalizer. Your thought on that?
Well, that's great, Sam. I mean, you did but it's a Band-Aid. So in other words, it's not going to eliminate the issue. And there are other issues too. Just because we've got a particular peak, typically at 70 hertz, who knows what the Q is, who knows where the other resonances are, and your structure is different from mine, and it's going to be multiple connections and cavities and materials that make up multiple resonances. So I just use one example that is typical and pretty strong. But yeah, to isolate would be the better solution, to eliminate the structure from playing back altogether. not only from resonance, but from buzzes and rattles as well.
Okay, thank you so much.
Okay, we'll go back to the raised hands for now. George, go ahead.
Great. Okay, so what's the best way to isolate a turntable? In my particular instance, I have a George Merrill polytable that has isolation feet as part of his system. But to increase isolation, should I use you had mentioned platforms or just another individual footer under his feet? What would you recommend?
Am I wrong, or is the motor a separate entity?
The motor is separate.
Yeah. So this is, and I've got a well-tempered table. I know Mark does too. And so we've got that situation. And so the way I addressed that was I had a custom piece of granite made the size of the table. And I ended up doing some modifications to it too, because even the solid granite still has some ringing. So I added a constrained layer damping material to it. And that way now I can put both pieces. I don't have to isolate them independently, which is tough to do, and get it balanced well. And I've got 5 2-inch EVPs under that platform. So that's the way I addressed it.
But this raises an interesting question. I still see turntables that come out with like tiptoe style feet on the assumption that these feet are mechanical diodes. I've been reading about tiptoes being mechanical diodes for 3 decades. What's wrong with that idea?
Well, when Steve McCormick came out with tiptoes back in the, early 80s or mid 80s, and I was a dealer, Steve didn't know what was going on. He just knew that it sounded different. And as again, I explained earlier, we are often fooled into thinking that if it's louder, it's better. But again, it's going to be different in every single situation. So if I change the material, or I change its shape or size, or the resting platform, or the load on it, those are all variables that are going to alter the end result. With the EVPs, you're not coupling, you are decoupling, you're isolating, and you are isolating from 5 hertz on up, 90% conservatively. The resonance, what they call the natural frequency of the EVP, is 3.4 hertz under proper load. And they are effective right away from 5 hertz on up. And again, you can see the transmissibility lab results. They are effective from 5 hertz on up. So even like a turntable on a surface area, we get this a lot. You've got a customer that says, I've got feedback with my subwoofer and my turntable. Or when I walk across the room, it causes mistracking, or I can hear it or whatever. That's typically around 7 hertz. With the EVPs, it eliminates it. Where you're coupling, you're just altering the sound, and you are not isolating, you are coupling.
Mm-hmm.
And it's going to sound different. And granted, you may like the sound, but it's not neutral, and it's not predictable, it's not natural, and it's not repeatable.
And
what's a tiptoe? Sorry to
tiptoes were an aluminum cone that Steve McCormick came out with as an accessory, an audio accessory back in the 80s. And he made 2. One was pretty long, and the other one was pretty short.
Is it like an upside down pyramid shape, or?
But cylindrical.
Right. They were in the 80s and 90s ubiquitous. I mean,
yeah,
everywhere. Everybody used them. I've got in my closet like probably 20 or 30 of the 2 sizes. So,
I love Steve, but I got to say that now I'm competing against the idea of coupling versus decoupling.
Right. The other thing with a turntable, of course, where you have a motor producing vibrations, and even the stylus itself vibrating the record, which goes into the platter, which goes into the bearing, and there was this thought that you've got to get those vibrations out of the system. You don't want them reflecting back. And thus the mechanical diode, the idea was that those vibrations go out of the turntable and don't come back because of that sharp little point.
Absolutely wrong.
Thank you.
100% absolutely wrong.
Right.
Remember, vibration is a two-way street. And again, now where this idea came up with, I haven't a clue, but there is no confusion in other industries about this. This is basic physics. There is if you go to the avroomservice.com EVP landing page and you scroll all the way down to the bottom, you will see, I went to a customer's house and I was there doing room acoustics and helping them out with room acoustics. And I noticed that he had a half a dozen different types of footers around. And so I asked him, hey, can I do a quick little, would you videotape me doing a quick little demonstration with a music box? Now, the music box has these, this is what I do at the trade shows too, in person. It's sometimes very hard to do because the noise floor is so high. But the tines on the music box are moving plus or minus 1 millimeter, okay? Not very much. And they are going from about 500 hertz on up. We're talking about a very, very small amount of energy, not like what we are talking about when we are coupling a loudspeaker to a surface area. Now, I take that music box, it's just the music box mechanism, no box, no resonator, no sounding board. And I play it in the air, and you can hear it, but it's hard to hear. And then I couple it to the table, and it is 27 dB louder. It's very easy to hear. And then when I asked him this, he goes, oh, I've got more than that. He had, I don't know, like 10 or 11 different kinds of footers out there. And so I just lined them up and put them in between I placed the music box mechanism on top of the device under test with the table underneath. And you can hear, and I think I'm going to put together a montage of them side by side. Here, I've got a little break in between. You can hear they all sound different. And then I do the EVP at the end, and it's actually quieter than it is in the air.
You talked about solid granite underneath the table. I and other people will use like a hardwood, typically a maple, butcher block, etc., as their support underneath the table. Any feelings on that versus granite?
Well, granite is just a little bit more inert. It's a more mass. Doesn't tend to have the resonances that other materials, even other types of rock do. So that's why. But then, like I say, that slab rings, and it weighs like 95 pounds. So I've got a material on the bottom of that to help with the ringing of it.
Interesting. Okay. Edgar Leonard, you've been very patient. Sorry to hold you up. Go ahead and unmute and ask your question.
Thank you very much. And I've enjoyed the entire conversation and the questions. Much appreciated. Norm, my question is about my speakers, and if this is better taken in a separate call, let me know. I've got NOLA Concert Baby Grands. Do you know them?
I don't.
But Carl, who makes these speakers, has a very interesting concept in that he has a platform underneath the speaker that has ball bearings. And I'm interested in trying your devices. I guess the question is what he had was spikes originally, and now I have still points. Would it be better, in your opinion? I mean, I could try both of these ways, but any thoughts about that?
Yeah, those are coupling devices, not decoupling devices. So they will transfer vibrations uniquely and very efficiently. So yeah, not what I recommend. There on this video that I was telling you about at the bottom of the EVP landing page, it's just a short video. You'll see similar devices and you'll hear what they do just with a tiny amount of, I mean, we're talking about tweeter energy. We're not talking about big low frequency energies, and yet listen to how they amplify and are unique and color the sound. And again, the resting platform, your room, your structure, the materials and methods will all be unique. And so it will again be different. And if you let's say you like that sound and now you put it in a different room or a different whatever, it's going to be different. Not the case with the EVPs.
Got it. Thanks, everybody. Appreciate you letting me ask the question.
We'll move on to Richard Atkinson.
Can you have too much isolation? I have my turntable with ISO acoustic feed on top of a maple. I'm sorry.
Right. Yeah, the answer is no.
Okay, thank you.
Yeah, but like I say, it has to be complete isolation. Once you've got complete isolation, you have complete isolation. If you add more isolation, it's not going to change.
Thank
it's either you got it or you don't. Now, I need to qualify that. I did say complete, didn't I? So there's various forms in between of, even these, couplers. Like I show on the graph, there are some areas where they do attenuate the sound, but then there's also resonances where they amplify the sound. So anytime you're talking about a coupler rather than a pure, true isolator, you're just changing, you're just filtering, you're just altering the sound and not really isolating it correctly.
Arnie, did you have a question or did you want to just,
No, it's been commonly experienced by many people that listening at 5 p.m. or, around dinner time or even in the afternoon to the system sounds completely different than what you can hear at 11, 12, 1 o'clock at night.
Yeah.
The theory being that, a lot of stuff gets turned off, a lot of PCs get turned off, people are not using their cell phones, et cetera, et cetera. Dishwashers are not likely to be going at that time. It's again, et cetera, et cetera. Can that be used as shall we say, an estimate of how bad your power line is contributing to your sound, how badly it's contributing to your sound? Because in some areas, I'm sure that you can listen at 5 p.m. Or 11 p.m. and the sound is likely to be the same unless something is coming, into your system on your own, level with your own dishwasher or whatever.
Right. Yeah, that's absolutely true, Arnie. And I live far from the city, and so cleaner power than if I lived in the city, where a lot is put on the grid, and power factor correction is a lot of what you're talking about. Not only the internal computers and low level energies, but in the city, people will especially notice it sounds better at night when the world, the grid around them is that they're connected to has quieted. And power companies, they work on changing power factor correction. We're talking about current and voltage phase being off, and they make constant adjustments regarding that. But sometimes they do a good job, sometimes they don't, and again, depends on where you live and the conditions and so forth. But you're right, Arnie, that is real common to experience, that the system sounds better at night because the electrical power supply is better.
Please let me add one comment that I have. The noise floor is also going down tremendously in the night. Mm-hmm. So, and you talked about in the beginning, that is for me a tremendous part of that equation and that discussion. Background noise is going down tremendously in the night.
Yeah. Oh, definite point. Yes. Yep. Traffic and air, both in the air and on the ground. You're right. Again, where I live, and then a room inside of a room and all of that, I don't have that issue. But for example, if if I were watching a movie and it was an underwater movie, and I heard an airplane interrupt, that would be disconcerting, or I was in space and I hear a car horn, a truck or something like that. It pulls you out of the experience. So yes, outside noise infiltration is to me, it's really important, because those distractions remove you. And then it's very hard. It'll take you 20 or 30 minutes after a distraction to get back into the zone.
Mark, can you see that my hand is up?
I do.
I have a question.
You didn't use the hand raise feature of Zoom, so I had no way of knowing that.
My hand has been up for quite a while.
Well, that doesn't count, does it? So, all right, Ross, go ahead.
Should I go now?
Yeah, go now.
This is a wonderful presentation. I'm really glad to have been here for this. My question is about the effect of near field listening for speakers.
Okay.
Where the speakers are and the one listener form a triangle at one end of a room, and the music is heard not from the speakers, they drop out totally, and the sound is a picture across the width of the room, all the way at the far end.
Mm-hmm. Yeah.
How would this sort of speaker arrangement affect or determine some of the things that you've been speaking about?
Right. So what you're talking about, Ross, is called the critical listening distance. And what that is, and again, this is measurable. So near field would be within that distance, far field would be without. And what's going to do, what it is a ratio. Well, actually, the critical listening distance point is where the energy from the direct airborne loudspeaker arrives at the listener or the microphone, and the sound energy that is reflected back from the room are equal. So if you're inside of that listening triangle, as you mentioned, then you begin to change that ratio, and you begin to eliminate, you're hearing more of the direct sound, the direct airborne sound, and less of the room reflected sound. Now, what determines that obviously is distance between you and the source, as well as distance between you and the boundaries. But in addition to that, it's reverberation times. So if I've got a lot of hard reflections, then that sound is continuing on bouncing around for a longer period of time. And so that's more and more destructive and destructive and ruining low-level detail and dynamic range and articulation and everything, really. So yeah, ideally you want to be within that, and you want to control the first order reflections and the reverberation times so that you're hearing the direct sound rather than your room. So yeah, measurable, absolutely.
In your case, the listener is not near any boundaries and the speakers aren't near any boundaries, and you're listening in the near field. But
yeah,
right. So Ron Nagel, go ahead.
Okay, you talked before about grounding your system.
Yeah.
And I live in an apartment building.
Yeah.
And I was wondering if running a wire to my system power supply from a water pipe, like a radiator, would do anything at all. The other thing is computers, desktop computers, a significant source of noise, electrical noise.
Okay, well, Ron, it's hard to say, but in general, such like an apartment like that, they're using the cold water pipes as the ground, and is sufficient, is usually very good. again, you'd have to have it checked and see. But normally, commercial places like that are well grounded.
He also asked you about a desktop computer contributing to line noise.
You bet. Yeah. I mean, they can absolutely. Not only can they contribute, but they're also very sensitive. Yeah.
Thank you.
All right, thanks, Ron. Don, try to keep the questions short, but take it away.
I'm ready. All right.
Okay, thanks.
I live in a fairly small condo, 8-foot ceiling in my listening room and about 200 square feet. Bookcase is full of 12-inch vinyl LPs. With those, I would assume those would tend to damper all the reflections and refractions and make it a little bit easier to get good sound in the room.
I mean, if you staggered them, you might, it might help a little bit. If you staggered them, you might introduce some diffusion. As far as absorption, or had cavities, spaces in between or whatever. Just like now, books are going to be more of an absorber than vinyl. Vinyl is pretty dense, pretty solid. So it's going to act, if you stagger them, more as a diffuser than an absorber, and that can help with first order reflection points. Yes. Another thing that's that is effective is large leafed plants. They can be plastic. That's a great thing to put at a first order reflection point, and it's incognito.
Mm-hmm. And if you can see, the front edge of my speakers hang over the front edge of a bookcase. I have a couple bookcases that my speakers sit on, and the bookcases are about 36 by 36. And they're jammed full of LPs. So there's 300 or 400 pounds worth of dead weight. And my speakers sit on top of those with the front edge of the speaker 2 or 3 inches in front of the bookshelf. Okay. So that would also be a good arrangement?
Well, yes, and no. You've introduced a lot of mass, and that's good. But you can't consider it as like an inertia block or something, because you don't have any isolation in the system. It's a conductor.
Okay.
So yes, you've got mass. It's probably not resonating. It's probably pretty well damped, but it is transferring vibrations to the structure and back.
Okay. One last really quick question. Where was the audio store that you used to own in California?
Oh, that was in Grass Valley, Alta Buena Stereo.
That's Sacramento area?
Yeah, north of Sacramento. You know where Nevada City is?
Sort of.
Okay, well, so it's right in the if you're going up 80, it's right in the foothills on the way to Tahoe. I had that for about 12 years.
Oh, okay. I live in the San Diego area now, and your presentation here has inspired me that I'm going to get in touch with my local dealer and have them come out and look at my room and take measurements. And before spending money on speakers, I'll spend money on room treatment.
Excellent. I love to hear that.
Nice. Thanks,
Cool.
Don. Stephen Scharf, go ahead.
Yeah, I don't have a question per se. I just want to give an enthusiastic recommendation for Norm's services. Norm, we need to chat offline about some other things. We haven't chatted in a while. What I will say, a couple of years ago, maybe 18 months ago, and I'm sure, Norm, you probably discussed your EVPs, your electronic vibration protectors to some extent. I'm really sorry. I just got this from Jeff like a little while ago. But anyway, I'll just relate very quickly a story that, based on Norm's recommendation and expertise, I put a set of EVPs under my REL subwoofer, and it was one of the biggest improvements I've made ever to my system. And when I discussed it with Norm and I read the theoretical underpinnings of why this works, basically it made the room quieter. That's the simplest thing I can say. But it took out a lot of resonance between the floor connecting the drywall, which resonates at 70 hertz, and made the room considerably quieter and really improved the presentation. So I want to give an enthusiastic thumbs up to Norm's EVPs. They really work. They're not fancy looking, but they're grounded in established principles of physics, and they do the job. other than that, with respect to grounding, I should probably contact you guys offline because I've been collaborating a lot with Shinyata on their soon-to-be released grounding product and have learned a lot about the importance of grounding at all applications, particularly digital. And if you happen to own a power distributor that has a ground terminal on it, that is, goes to chassis or earth ground, or you have products that have an earth ground terminal on them, like many of the Asian products do, Lumen, Arinder, things like that, you should use that ground terminal and connect it to a proper earth ground on a power distributor, because it will make things notably quieter. So we can talk about this more offline if you want some time, because I've been doing a lot of work on this. And lastly, I'll just give a big thumbs up for Norm's services. If you need a room, Norm, for consulting, for rooms, he's your guy. So that's kind of all I wanted to say.
Thank you so much, Stephen. Appreciate it.
Yeah.
Very good. And Lawrence Brown from San Francisco, you'll be our last questioner. Thanks for joining us.
Thank you very much. Hope you can hear me.
Yes.
I have a quick question I don't think has been discussed yet. And it has to do with electrical noise and the discussions about transformers and isolation transformers and things, and briefly Norm's comment about, in general, power conditioners. And that is, there are, the last several years, there's been many companies or several companies, and I'm sure most people know who they are, who've now talked about component to component noise or component induced noise affecting other components in the systems, in their audio systems, as being much more important than noise coming from the outside via the grid. The discussion we've had so far that Norm has been addressing are noises kind of like coming from electrical noises coming from outside the listening room, like via the grid or other things. Can you make any comments? Do you have any feelings about these component to component noise issues, supposed noise issues, and if how real are they? And if they are there ways that we can control them, or I don't know, your feelings?
They're real for sure. They're less common than the other external interferences that we've been talking about. And typically, if there's a problem, then I'd say it's, there's a source in the system that is the problem. Usually it has something to do with, of course, it could be anything. It could be EMI or RFI type of interference, either line coupled or field coupled, or it might be an impedance mismatch. But in general, I'm saying that if there's a problem with a particular component introducing noise, then I would call that a problem, and it should be investigated and determined and rectified.
May I just add a quick comment to that, to piggyback off Norm? Most of the noise in folk systems comes from the full wave bridge rectifiers and the power supplies of the components themselves. And because it's AC, the current goes both ways. It goes in the component and back out of the component. Yeah. So this is why this component-to-component isolation approach is so important. Most of the noise in your system comes from the gear in your system's power supplies.
Yeah, we talked about an isolation transformer for the system, but I recommend isolation of all the components. Like, for example, with what I did for Skywalker back, their scoring facility back in the mid 90s, that was pretty innovative. Now they had their own power source themselves for their place. Their own fire department. They were completely off the grid. However, the scoring facility still had issues. And so what I introduced besides a technical grounding grid was lots of isolation. They already had a separately derived system, but what we ended up isolating in addition was analog from digital, recording from playback, and so forth.
Norm, thank you so much. How's the weather there?
It has mellowed out just recently, so we survived.
Okay.
That's a good thing.
Yeah, so at least you didn't get taken off the grid.
Right.
And neither did I. So very successful meeting. And thank you so much for doing this. And thank you for hanging out for so long. It's been great, very educational, entertaining, and but we had so many questions, and I think we got good answers. So thank you so much.
Great. Well, again, thank you so much. And you know, if there's some topics that you want in the future, I'm here.